Yo, what's up guys, and this is going to be my RAM tutorial. So I tried making some shorts on it, but I realized that they were very vague and didn't really explain why this works. So I want to make an actual video on the tutorial going a little more in depth on how it works and why it works. So this is what our finished result should look like, but let's start building it. So if I just come over here. So let's start with the very fundamental concept that this RAM module is based off of, and it's that you can lock repeaters and comparators just in slightly different ways. So I just want to put a lamp there to show you guys that there's a signal there, and then if we have a comparator, make sure you click it so the little bulb turns on. That means it's in subtract mode. And so we can just set up a little really basic memory circuit that looks something like this. And so these are going to be knotted, so they're always going to be on. So notice right here, something happened to this repeater. So this repeater is now locked. It gives a little bar over it. And so what happens when there's a bar over it, it means that no signal is allowed in. So if we were to unlock it, then we notice that, the signal can go through it as usual. And if we want to lock it, it saves the state. So if it was on, it stays on. If it was off, it stays off. Now let's talk about this comparator over here. Comparators can take a signal strength and they have the ability to subtract it. So they subtract the signal strength from the side from the signal strength from the top. But why I use the comparator is that when the signal at the top is equal to the signal at the side, it's equal to 0, which is pretty obvious because anything minus itself is 0. But what this means is that it will output a 0 if you have a equal signal or greater signal going into the side. And so this allows me to either unlock or lock the comparator. And so this way I can manipulate a single bit. So what I can do is I can input a bit, right? Nothing can change it here. And I can choose when to output a bit. So this is cool and all, but what am I going to do with a single bit? You can't really make a computer with a single bit. So what we're going to do is we're going to stack this. We're going to have multiple of these together to create larger amounts of data. So what I'm first going to do is I just want to break the input and output. We can leave that little middle piece. We're going to just get rid of these, and instead we're going to place a slab here. And then instead of having the signal going into the side of the comparator like this, what we're going to do is we're going to create a little circuit like this, where we have a repeater powering this redstone, which is powering this comparator, and then we're going to place redstone here, and then we're going to have a block, so the redstone is going to go through the block and be outputted right here. Now we break that block, and we place a slab. And if we place redstone and redstone, this, and if I just place a little redstone for my input, this is going to be the main memory unit. So this is basically just the same unit, just stretched a little. And this is because I'm going to be stacking it next to each other, so I want to make this as stackable as possible. And so what we're going to do here is, if you have world edit, you can just select that block, and then you can build up here, and then select this block. Then if you do // stack 7u, you have 8 of these, and this is called a byte. So you have a single byte of data here. But notice each bit is still individual, and this is why I place the slabs here. So what I'm going to do here is just create a slab tower. I'm just going to make this easy. Just stack 6 up, and then I'm going to go over here, and I'm going to stack 6 up. Stack 6 up. So now this is still the same layout, but we can control a whole byte of data, a whole 8 bits of data. So what I'm going to do here is I'm just going to replace these with solid blocks, and like I said before, the input's going to be knotted. So if I can just place a redstone torch below it, and now everything is locked. So then I can give it, a binary number, maybe like this, which is 18. And notice nothing's going in right now, but I can choose to save it. And now with the lamps make it easy to see, you can see that the number is saved, and then right now nothing's being outputted, and if I unlock this, it outputs the 18. So I can control a byte of data like this, but one byte of data isn't very much. So what we're going to do is we're going to stack it. So I'll just go down here, just grab any corner, and then I'm going to go up to this top corner here. I'm going to select it, and then I'm going to stack 7. So now we should have 8 bytes of data. And then what we're going to do is we are just going to connect up the inputs and the outputs so that we only need one input. We don't need 8 different inputs. So I'll just put redstone along here. And what's nice about making it in 8 is that you don't need to add any more repeaters because the signal strength won't run out. So I'm just going to stack 7 down. And if we just put an input, so we go count 4 over from left and right, we can put a repeater with a lamp and a lever. And then what we're going to do is we're just going to stack 7 down. And so this way we can flick one lever and it can access all 8 bytes, or write to all 8 bytes. And then we're just going to do the same thing, but with the output. So we're going to build over here, and then, oh, one more. And then we're going to put redstone on this, and then we are going to copy it, and we're going to stack 7 down. And then we're going to do basically just the same thing, but with the output. So repeater into a lamp, and then we are going to stack 7 down. And we can test this out right now. We can put in a number, maybe like we can put a number like this, and then we can pick a cell to write to. So maybe we want to write to this cell, and then we just unlock it, lock it briefly. So now we see that that cell contains that number, and then we can choose another cell, so we can write another number, we can unlock and lock another cell, and you see that that cell contains the number 7. Now we can go to the outputs. We can choose what to enable. So if we just got to find a cell that has a number, and if we flick that, it outputs our number. And so this way we can store multiple different numbers. So this is a little annoying with 8 bytes. Maybe you could deal with maybe like 10 or 12 bytes, but after that it just gets ridiculous. So what I'm going to show you is how to make a decoder, which allows you to access it by giving a binary number. So we're going to grab target blocks, we're going to build down 2, break the middle, place a torch, and then we're going to take a slab, build down 1 and place your slab. We're going to build over 3 blocks, break the 2 in between, and then build down a block and place 2 slabs. And then what we're going to do here is we're going to place redstone on all of them except that one. We're placing a repeater there. Make sure you're using slabs here and solid blocks here, because that's going to be important. Now here we're just going to make a mini slab tower, and because we have 8 bytes of data, we only need 3 binary digits. So if I just build up here, now for this very first one, this very first cell, we're going to access it by 0, 0, 0. And so right now, notice how it is actually unlocked right now. And if we were to put in any other combination, maybe like a 4, it turns off, maybe like a 6, it turns off, a 2, it turns off, any other combination that you can think of, it will be off. The only combination where it unlocks this cell is 0, 0, 0. Now what we're going to do here is just break these real quick. We're going to build out 2, build out 2, build out 2, place redstone on here, and then we're going to copy this bottom part here, and then we're going to copy this top part, and then we're going to stack 7. And so these should be lined up. So make sure all the torches are lined up. But notice everything, I'll break these real quick. Notice everything is unlocked. So every single cell is unlocked. So we want to fix that. So we want 0, 0, 0 to unlock this one. We want 0, 0, 1 to unlock this one. We want 0, 1, 0 to unlock this one, and so on all the way to 1, 1, 1. So how are we going to do that? Well, if you see here, we use repeaters for 0. What we're going to do here is if there's a 1, we're just going to replace it with a torch. So this is 0, 0, 1. We're going to place a torch at the bottom. If this is 0, 1, 0, we're going to place a torch here, 0, 1, 1. We're going to place 2 torches here, and so on. So you're just counting up in binary in increasing order, and you are just placing a redstone torch wherever there's a 1 and leaving it as a repeater wherever there's a 0. And then just to make sure the signal reaches across, I'm going to place down some repeaters here. And then that is our decoder. We can just put some lamps here. So we have 0, and you see that torch is off there. If we put in 1, that torch is off. If we put in 2, that torch is off. We put in 3, that torch is off, all the way up to 7, where that torch is unlocked. So now what we're going to do is we're just going to copy this onto the other end. So if we build down here, just copy that corner, and then we build out a little bit here, and copy this corner. What we're going to do is we're going to go up to this block, we're going to copy, we're going to flip left, and then we're going to go over here and we're going to paste. And then if we go down here, we'd have 2 identical decoders just mirrored. So this one works as well. You see that we can put in a 4, that one's unlocked, 5, that one's unlocked, 7, that one's unlocked, and we can put back to 0, that one's unlocked. Notice for this cell, the input is constantly unlocked and the output is constantly unlocked. And this is because it is identified by 0, 0, 0. And so because there's no signal going into the decoder, it just says, okay, well, the 0th cell must be unlocked. Well, how can we fix this? Well, if we look at this decoder, what makes a cell locked? Well, it's by powering this block, which then powers the torch, which powers this torch, which powers the whole line. So what we can do is if we just power the target blocks, every single target block, then none of them can unlock any of the cells. And this is why I wanted to use the target blocks, because they redirect redstone signals. And so we can easily just make a line right here, and then we can just build over here, can just do the exact same thing on this side. And so now I have the wires here, and then what we can do is I just want to make sure the signals can reach the other side. And so I'm going to knot the inputs, because whenever the input and outputs are off, we want nothing to be unlocked. And notice this fixes our problem. So our first cell is no longer unlocked. And so what we can do here is we can choose to input something. So we can maybe let's put in a 5, and we're putting it to cell 3, which is right here. So notice this is off, but because our input is still locked, it is turning off this torch. And so whenever we want to turn it on, it allows this torch to turn on, turn this torch off, which then allows the signal to be inputted. And then we can just flick this off, and now it is memorized. And then we can do the same thing on the other side, and then we can choose what memory cell we want to unlock on this side. We can put in a 3, nothing's coming out, but we can unlock it, and we have our 5 coming out. And so you can do this with any of the memory cells. So that is our RAM. Now you guys might be wondering, okay, well, why did I go through the trouble of making 2 decoders when I could have just easily combined them and could have just been accessing the cell and then could have chosen to read or write? And that is because you can use this to, instead of using it as RAM, you can actually use it as registers. The registers are kind of what you're working with in the computer, like the most immediate values you need in the computer. So they're more immediate memory than RAM. And so a lot of the times you feed registers into themselves. So what I could do is I could connect up the output of this RAM, this memory, and feed it back into itself. And then what I can do is I can move a value from a certain register, so I can enable a value from a register and set another register, so I can move values around within this memory. And so that's why I'm accessing it with 2 decoders, that I can have one to set and one to enable in case you want to turn this into registers. So that was my new tutorial on RAM. I hope it answered a lot of your guys' questions. If you have any more questions, feel free to comment, but that's about it. Peace.